All right, so in this problem, we are asked to solve this equation. Sine of x equals negative 0.51. All right, let's think about what this means. So let's draw a unit circle and see what we're looking at here. So here's a circle of radius 1, centered at the origin. Okay, so remember that sine of x always gives us the y-coordinate of a point on the circle. So we're looking at points whose y-coordinate is negative 0.51. Well, I see there's a point over here, and there's a point over here. So what I'm looking for are the angles that get me to these points. Now, there are an infinite number of angles that will get me there, right? I can go around to here and look at this angle, right? The one that takes me to here. I could go further than that. I could go around to here and go take that angle. That'll get me to there. But I could also go this negative direction. I can take this negative angle and get here. And I could go a negative angle and get to here. Or I could even go around the circle 2 pi and then go that far. There's an infinite number of angles that'll get me to these points. Now, it specifies, however, that it only wants the angles, x, that are between 0 and 2 pi. All right, so keep in mind that we always measure angles in radians in mathematics unless specified otherwise. It doesn't say anything about degrees, so we're thinking radians. So between 0 and 2 pi radians. So of all those angles that we looked at, I can see which ones I need. I need the one that's measured counterclockwise there, that angle, that's one of them. That's going to be angle A. And then I need this angle over here, that's angle B. Those are the angles I want. This one, however, is no good because this is a negative angle. It's outside of that interval, right? Okay, so how can I find these angles? Well, this is what the inverse sine function will do. If I use the inverse sine function, or arcsine, it will give me the value of x that corresponds to this y value, the angle that corresponds to this number. So if I use arcsine, I can say that one such angle will be this one. Arcsine of negative 0.51, which, if we approximate it using a calculator, negative 0.5352 approximately. I'm rounding to 4 decimal places. All right. Is that one of my solutions? Well, this is an answer, but it's not one of the answers that we're being asked to find, right? We're being asked to find these angles that are in this interval. So while that is an answer, it's not one of the answers that we need. So how do I get the answers that we need? Well, this angle here comes from arcsine, and arcsine will always give me an angle between negative pi over 2 and pi over 2 radians. Negative pi over 2 is down here, and pi over 2 is up here. So this right here is this angle right here. So we just found this one, but that's not one we want. So how do I get this to become A and B? Well, I think I can easily get to B, because you can see one way to get B is to go all the way around 2 pi radians and then back up this amount. So if I just take 2 pi and add this number to it, I will have B. So B is actually equal to 2 pi plus this, or in other words, minus 0.5352. And how do I get A? What I need to do is go pi radians and then go this much more. Well, this much more is exactly this quantity, but positive, right? So this angle right here is, and I'm going to add that to pi radians, because pi gets me to here, go that much more, and I'll have A. So the answer for A is going to be pi plus 0.5352. So by looking at the circle, you can see that these are the answers. Now, I could have reported these entirely as decimals. All right, so instead of writing pi plus, I could have computed that out as a decimal, and you'll see that what we get is 3.6768 for A, and 5.7480 for B. And you'll see that this is also a valid way to answer the question.